Ladies and gentlemen, hello again, and welcome to another Reflected Reality Simulations video. My name is Graham. We're looking at the Hot Start Challenger 650, and today we're going to take a detailed look at the fuel system, refueling the aircraft, understanding how we balance the fuel tanks, and basically looking at the fuel system in a little bit more detail, answering the questions the community's had about the aircraft. The Challenger fuel system is perhaps a little bit more complicated than you may have expected, so let's see what we can do to clear up some of the confusion around that. In the aircraft here, I've got the aircraft running on the APU. We've got the study screen popped up here. It's important to realise that the information shown in these windows here is part of the simulation. It's not something the pilots or indeed the aircraft know about. So that fuel level there, that is what the simulation knows about, not what the aircraft knows about. We've got the refuel truck here, and we've got the interior fueling panel popped out as well. I've got the CAS showing here, so you can see any alerts we get, and I've got the fuel panel on the overhead here. So it's a little bit cluttered, but we're not going flying today. The objective is just to understand the fuel system. We've got about 60% fuel in both the right and left main wing tanks, and as I said, APU feeding off the right tank here. The first question that a lot of people have had is how the shut-off valves work, because it doesn't seem to make sense the first time you look at it. So let's flick the switch to fuel. We've got open lights, we've got closed lights, and high level lights on here. We've got the quantities that the avionics can see. When you first power up, it'll take a little bit of time for those to come up to level, and the total quantity is just summing up those values there. And the first thing people do is they switch the shut-off valves to open, all of them to open, and then wonder why the lights don't come on. Only those two lights come on, and they think, well, that's not quite right. Let's look at the refuel system here. Those two lights refer to these two valves. So if you keep an eye on these valves as I'm talking. You've got 5 valves on the Challenger. You've got the left main, the right main, the aux valve, and the 2 tail valves. The tail valves are controlled electrically. The other valves require fuel system pressure to operate. They are basically sprung loaded to close, and they require fuel system to open. Fuel system pressure to open. You'll see that without me doing anything, the tail valves have also closed. Although they're electrically signalled, because they are on either side of what they call the rotor burst zone, the designers wanted to make sure that those valves would close positively all the time, so they're closed by electrical servos. So what I'm going to do is leave all the valves switched on, and then I'm going to start up the fuel truck pump here. Notice that they're all selected to open. We've had the tail and the aux open for quite some time, and the tail has timed out and closed by itself. Let me push start on the fuel truck, and you can see it's putting fuel into the left main and the right main, but not the tail and not the aux. That's because the tail and the aux tanks are linked, and because the tail tank has timed out, the aux tank is also signalled not to open. So we've got the left valve, the left wing valve open, the right valve wing open, and the aux valve is closed. So that kind of makes sense hopefully now. The tail valve is electrically signalled, the other valves need fuel system pressure. Just to make that live, if I finish the refueling, I cycle the tail and the aux from open to closed to open, and then once it's in the open position, then I start pressure. You'll see that all of the valves open. But the valves are linked. If I close one, all 3 of them have to switch off. It takes a long time to fuel the Challenger. It'll take up to half an hour if you're filling it up to full tail fuel. I don't really have time for that. So what I'm going to do is click the mode button on the fuel truck here. I'll select the next page here for pump speed, and one of the concessions to simulation is the unrealistic refueling pressure. I can set the pump speed to unrealistic, push enter, and now I've got a very rapid fuel delivery. I want to show you the fuel system imbalance. So what I'm going to do is close all the valves but the left main. I'm going to fill the left main up to around about 90, let's say 90 to 95%. Now it goes very quickly, so I'll do my best with this. So now it's filling incredibly quickly. When I get to about 90%, I'm going to click finish. There we go. And you can see that we've got just over 2 tons of fuel in the left tank that the simulation knows about. The avionics only know about 1.7 tons. You can see it's slowly increasing. So that's another question people have, is why when I've finished fueling are my fuel values continuing to increase? The fuel level isn't increasing, the fuel level is where it needs to be. It just takes the avionics a little bit of time to measure the fuel. You can see the fuel level sensors here. You can see that they're gradually increasing on the left hand side. The bing was the fuel imbalance warning, which is expected based on what we've done. So these sensors take a little bit of time to basically filter the information and present it to avionics. The idea being, if you're flying in turbulence or you're moving aircraft around a little bit, you don't want the fuel valves, or the fuel gauges, sorry, to dance around all over the place. You want a nice filtered output on there. So once you finish fueling, especially on the unrealistic speed, it will take a little bit of time for those figures there to settle. And that's also the same if you start from cold and dark. As soon as you switch the pumps on or the avionics on, it will take a little bit of time for the fuel levels to stabilise on the avionics. So now we've got fuel imbalance, and this is something that we've seen a lot with new pilots to the Challenger. The reason being, you start the APU very early on in the procedure, and then as you're learning the aircraft, you get a lot of APU burn, maybe more APU burn than you'd expect in real life. You know, you take a couple of hours the first time you get there with the APU running to read all the procedures. And as the APU is feeding from the right tank, it depletes the right tank, the left tank stays where it is, and you get the fuel imbalance. I'm just going to switch this panel off to make sure there's no confusion about what I'm going to do now. This isn't a refueling operation we're looking at, this is a fuel balancing operation. So the left wing is heavy and the right wing is light. Let me bring up the transfer system. And the valves we're looking at are left to aux and left to right gravity transfer. You might think that gravity transfer, gravity cross flow is the way to solve this problem. And if I open it, you'll see that this valve opens and it's moving around about 1500 litres per hour. If I keep an eye on this level here, you see it's going down slowly and the right main is going up slowly. This level of precision is only afforded to us by having this through the looking glass view of the fuel system. The avionics don't have that precision, so you can't see that happen. And although it's flowing from the left tank to the right tank at the moment, if I was parked on a ramp or an apron that was at a slight angle, slightly angled towards the heavy tank, so the heavy tank is on the downhill side, then the fuel is going to flow from the lighter tank into the heavy tank, thereby making the situation worse. So gravity cross flow on the ground is not approved. It's not something you do with a Challenger. Let's close that. The proper way to handle this situation is to use left to aux. Remember, the APU feeds from the right tank, so typically you'll have the left tank is heavier. I'm going to click left to aux and watch the left to aux transfer here. That opens up and it allows about 4,000 litres an hour to flow from the left tank into the centre aux tank. And if we left that for long enough, that would sort out the imbalance. You see the left main is going down and the centre aux is going up. That's the proper way to fix the imbalance. Now, if you get an imbalance and all of your fuel tanks except the right tank are full, you've already filled the centre aux tank, there's nowhere for that left wing tank to go, then you're a little bit stuck. What you have to do then is call the fuel truck back and top up the right hand tank. It can't be avoided. The best way to prevent that is to plan ahead, think about your APU burn. Don't run the APU if you're expecting a long time on the ground. And basically just call the fuel truck back if you need it. It's the only way to fix that. That's the imbalance in the system. I'm going to turn the left to aux back. I'm going to flick the fuel system back to fuel mode. And I'm going to open the left and right main for the wing and start the pump up again in unrealistic speed. And I'll fill the left and right main tanks. See, the left main tank gets to about 97%, and then the high level comes on, it closes the valve, and you'll get the same on the right. There you go, right tank, it got to 98%, high level's tripped, and it's closed the valve. I'll finish on the fuel truck there. Because the fuel truck is running at unrealistic speed, I want to be careful and make sure it's switched to finish, make sure it's not pumping when I don't want it to. So now we've got 2 full wing tanks, and a little bit that we drained in the aux earlier. I'll switch off the wing tanks because I'm done with those for now. The centre tank, the forward tank, and the aft tank are all part of the aux system. The centre tank is the lowest part of the system there. The forward and the aft tanks are slightly higher, so they will drain via gravity into the centre tank. I said previously that we've got to have both the tail and the aux switched on together. I'm going to reset my fuel pump for the moment into the regular pumping speed. So I'm going to go back to normal, enter. I'm going to open the tail and the aux, and then I'm going to click start. You see the symbol appears here for the gas nozzle, and we've got all 3 valves open. If I look at the refuel system here, we're putting fuel into the forward tank, a little bit into the centre, into the aux, and into the tail. Now you've got no way to apportion the fuel yourself in this automatic fueling method. If you say, actually, I want to put more in the tail, so I'm going to switch off the aux tank, well, you can't do that. If you switch off the aux, it closes the tail as well. And similarly, if I switch off the tail, it closes the aux as well, because both at the top and the bottom, it shows you the tail and the aux tanks are linked. Now that's not strictly true. There is a method to sort that out. If you get tail heavy or aux heavy because you've landed with an unusual fuel state, it's possible to fix it. So let's say I want to put fuel into my tail tank but not into the aux tank. I'm going to close the aux tank, and then I'm going to push and hold this override button. If I'm not holding it, it won't work. So when override is pressed, then the tail valves open and fuel will flow slowly into the tail tank. You see the saddle tanks increasing at the moment. The tail tanks, there's 3 of them there. It's treated as one tank as far as the system is concerned. I release override and the valves close. And it's the same if I do it on the aux tank only. I have to hold override to put fuel into both of those tanks. And this is basically to make sure that if you're controlling the fuel manually, that you are there watching the panel as you're doing it. It's not something you would just set a button, walk away and see what happens. There's a risk of tipping the aircraft on its tail. There's a risk of putting it out of CG limits. So the idea is that you always refuel tail and aux together. In the simulator, if you've got the aircraft into an unusual fuel state, you may have to use the override a little bit more than the real pilots. But if you stick to the normal operating procedures, you'll have no issues with it. So let's put the fuel pump. I'll finish the pumping here. I'll change the mode and I'll go back to setup. No, I don't want volume units, I want pump speed. I'll go back to unrealistic and I'll push enter. Now, let's fill up the aux tanks with the fuel set to this high speed mode, and keep an eye on the forward, the centre and the aux levels. Here we go. So all the valves are open. Notice the centre's going down and the forward and the aft are filling. I'll let that drain down and then I'll click finish. And what you can see is the centre tank is a little bit more complicated than perhaps you first imagined because it's divided into 3. Now there's no fuel pressure coming from the truck. There's no fuel being added to the aircraft. But you can see my forward aux tank will slowly start to go down. The centre aux tank is increasing and the aft aux tank is dropping. This one's lower physically than the other 2 tanks, and with no pressure and a gravity flow, the fuel will drain from the aux tanks, the forward and the aft aux tanks, back into the centre. The fuel flow goes through these check valves here into ejector valves, so you get motive power, motive flow from the fuel truck that picks any fuel out of the centre tank and pushes it to the forward and pushes it to the aft tank. So it will fill the forward and the aft tanks first, and then it will fill the centre. And we can see that if we leave the system to complete, more or less. So remember, these valves have timed out. I need to cycle them both off, back on, and then establish the fuel pressure. With fuel pressure, all three valves open. You can see the forward and the aft fill, the centre drains as those ejector pumps do the job. And then once the forward and the aft are full, you'll see that the centre starts to increase again, and that's the expected behaviour. Now remember, this is happening very rapidly compared to the real fueling rate. It just makes it a little bit easier to see. There is a gotcha in this situation, and it's something that's caught Challenger pilots out for real. Let me get to about 50% and I'll click finish, and you can watch that blowback happen. So there's no fuel pressure from the truck just now. The forward and the aft tanks are now draining into centre, as we saw before. So with a business jet, the fuel is almost certainly coming from a fuel truck. It's probably not coming from a hydrant supply like airliners may often have. If you're filling the tanks on a Challenger, you want to be 100% sure that the fuel truck has got enough fuel to finish the job. If the fuel truck is likely to run out or run low or have any pump delivery issues when your centre tank is nearly full, then you should request another fuel truck, because there's a really important trap in this Challenger here. The forward tank and the aft aux tank are draining into the centre tank, but it's only the centre tank that has the high level sensors. The high level sensor is only in the centre tank, and it's the high level sensor that triggers the shut-off. Okay, so let's see what would happen. I start filling again at rapid rate. Let me cycle the valves. So cycle both the valves, start fueling. All three open, forward and aft increase and centre drops. And then when the centre gets to around about 85%, I'm going to click finish. And that'll be me done with the fuel truck. So just coming up now, 70%. 80%. There's 85-ish. I click finish. The fuel truck's finished. And what's happening now is the same as we saw before. The centre tank is increasing, the forward tank and the aft tank are decreasing. At the moment, I'll switch all these valves to closed because I'm not interested in adding any more fuel now. The valves are closed, but keep an eye on the high level sensor for the aux tank, because as that fuel drains from forward and aft into centre, it will eventually get to the high level cutoff. And once it gets that high level cut off, there we go, the high level light is illuminated. I can't put any more fuel into the centre tank system. Remember, the high level is only coming from the centre tank, and the centre tank is still being filled by the drain down from the forward and the aft. So it's a bit of an awkward system, and at this point you are really stuck. If you need that extra capacity, if you need the extra forward and aft aux tank capacity, you can't have it. There's no way to get that fuel into the aircraft. You'll have to make a refueling stop or come up with a plan B. To demonstrate that, I'm going to switch the pumps, the shut-off valves back to open. I'll push start, and you see that all we're doing now is putting fuel into the tail because this aux tank is full. There's no way to get that extra percentage of fuel. The forward aux tank is only 77% and it's draining down. The aft is at 70%. Now they're fairly small tanks. The centre tank is where the majority of the fuel is. But if you're really stretching the range on the Challenger, that's an important consideration. And it's a real life thing. You know, if the fuel truck is likely to run out or likely to run low or reduce the delivery pressure when the centre tank is nearly full, you could very well get yourself into this situation. So there we go, we've got high levels on all of the tanks. Finish with the pump. I'm going to reset it back to the normal speed. I'll switch off the fueling valves. And you can see here that we've got, well, it's still integrating it, it's still calculating it, but we've got about 8.9 tons or so. So maybe half a ton short, maybe 300 or 400 kilos short. It really depends on where you got to when that center tank high level was tripped. But just something to be aware of. So we've looked at the left to aux to balance the wings when you've had some APU burn. We've understood that if the center tank is already full, we can't use left to aux because there's nowhere for it to go. So in that case, you can only balance it by requesting the fuel truck back. We've understood how the shut-off valves work, that we've got fuel pressure, electric, fuel pressure, and fuel pressure. We know that the tail and the aux tank shut-off valves will time out, and if they time out, you have to reset them. And we've understood the limitations on filling the aux tank, especially if we're close to a full tank required. We've got to make sure that we can have continuous flow from the fueler all the way through. I hope that makes sense. If you do have any comments or questions about the fuel system, please leave them in the comment section below, or visit the Hotstart Discord or the Xpilot forums to chat about it. I hope you'll join me again soon for another video. Thanks very much.